There, welcome to CXC Math TV, and today we're going through the Unit 2, Paper 1, 2021. I finally got access to it, so we're going to go through the 2021 Paper 1 for Unit 2. Alright, it's a little bit blurry, but that's how I received the paper from, one of my top students. So, alright, so we need to find the derivative of, this is ln 1 over cube root of x. Alright, so it's ln, I'm just going to call it y for simplicity. So let's call it y. Y is equal to ln, and cube root of x is x to the 1/3 power. So it's 1 over x to the 1/3 power. Now you can remember this is the same as ln. 1 over is just x to the minus 1/3 power. Now the rule of logarithm, when you're differentiating a log function, it says that dy by dx is going to be equal to f prime of x over f of x. So our f of x in this case is x to the minus 1/3. Alright, so our f prime of x is going to be carried on the power, so minus 1 over 3x. And we subtract 1 from the power, that is minus subtract 1 from 1/3, that's minus 4 over 3. So therefore the derivative is going to be f prime of x, which is minus 1/3 x to the negative 4 over 3 divided by x to the minus 1/3. So then now, remember whenever the bases are the same, we subtract the powers. So we're going to work out minus 4 over 3 subtract negative 1 over 3. Then we're going to put that in the calculator. So minus 4 over 3 subtract in bracket negative 1 over 3. Minus 1 over 3. Close the bracket. That's just minus 1. So anytime it's minus 1, it go in the denominator. The answer is just negative 1 over 3x. That's option A. I think it's a repeat question, but Unit 2, it's for some reason I find Unit 2 multiple choice a little bit difficult to just remember. So always have to just rework them. But I hope you do enough papers so you can just swat it. Now this is the quadratic, this is the roots, and they want the quadratic. So remember, quadratic is x squared minus the sum of the roots times x plus the product equals 0. So the sum is going to be equal to 2 plus root 3i plus the occurring conjugate pair, so 2 minus root 3i, 2 plus 2, 2 plus 2 is 4, so the sum is 4. Then now we need the product, so we need to multiply 2 plus root 3i times 2 minus root 3i. This becomes the difference of 2 squared. 2 times 2 is 4 minus, this is now root 3i being squared, which is 4 minus root 3 squared is 3i squared, but I squared is minus 1. So it's 4 minus minus 3, which is 7. X squared minus 4x plus 7 equals 0. That's going to be option C. And if you want, you can always check back your answer by putting it in a calculator. Alright, like this. So A was 1, B was minus 4, and C was positive 7. So you put it back in the calculator, you notice you get 2 plus root 3 and 2 minus root 3. So we know correct. Next one, they want the modulus of the complex number. Remember modulus, it's going to be x squared plus y squared square rooted. So half square plus negative half square square rooted. Half square is quarter plus quarter. Quarter plus quarter is half, so you have square root half. So I just put in the calculator. I want to know the square root of half, and they tell us that is root 2 over 2. And root 2 over 2 is 1 over root 2. If you don't believe it, check it. 1 over root 2, you get your root 2 over 2. Alright, number 4, we want the value of this here. So we're going to use the Moivre's theorem. So bring down the power. This is cos 4 times pi over 4 plus I sine 4 times pi over 4. Now, in this case now, this 4 cancel this 4. So cos pi is minus 1. Alright, and then this 4 cancel this 4 and sine pi is 0. This is plus I times 0, which is minus 1. That's option B. Question 5, we need to simplify this expression. Just going to expand it. First term square. So I being multiplied by first term square plus twice the product of the two, that's 4i, plus second term square, that's I square, minus, over here now, it's first term square, 4, minus twice the product of the two plus second term square. Now inside the bracket, we notice that 4 would cancel the negative 4. And we notice that I square would cancel the I square. So 4i minus negative 4i is positive 8i, because negative and negative become positive, but then it multiply by I. Then I times I is I square, so that's 8i square, but I square is negative 1. So it's 8 times negative 1, which is negative 8. That's not bad. This one now, if you factor out the minus, it's z minus in bracket 1 plus 2i equal to 3. So the center is 1, 2, and the radius is 3. So the center 1, 2, radius 3, C. This complex number now in exponential form, first find r, which is the square root of a square plus b square, so that's root 3 square. And you punch that into your calculator. Well, all of them give you 2, so you don't need to work it out. Basically, you just need to find the argument. So first thing you have to picture is which quadrant this is in. So just to give a little overview, minus 1 on the x, so negative 1. Then root 3 somewhere here. So the complex number is in the second quadrant. In the second quadrant, remember, it's pi plus tan inverse b over a. So the argument is going to be pi plus tan inverse of root 3 over negative 1. And then you put that in your calculator. Put your calculator in radians when you're dealing with 3. So you have pi, pi plus tan inverse negative root 3. Close the bracket. And that's 2 over 3 pi. So that would be option D. This question, given that x cubed y minus 3 is negative 6x, we need to find dy dx. So the first thing is differentiate both sides with respect to x. So we're going to use implicit differentiation, keep the first times the derivative of the second. When you differentiate y, you get dy dx. Minus, keep the second, which is y, times the derivative of the first. When you differentiate x cubed, you get 3x squared. And then when you differentiate the constant, you get 0. When you differentiate, so keep the first, yeah, derivative of the second. Then we have plus, keep the second times derivative of the first, yeah. Then we differentiate minus 6x, we get negative 6. Now they want the gradient, so you're just going to plug in x as 1 and y as minus 3. So that become 1 cubed times dy dx plus 3 times 1 squared times minus 3. That's going to be negative 6. So this is now 3 times negative 3. 3 times negative 3 is, I believe that's negative 9. So this is dy dx minus 9 equal negative 6. So if you bring it over, This is dy dx equal negative 6 plus 9, which we know is 3. Alright, so that's it. 3 is the answer, C. Not bad. Question 9. First thing, cos over sine is cot. So y is equal to ln cot x. So remember, dy by dx is equal to f prime of x over f of x. So in this case now, when you differentiate cot, remember when you differentiate tan, you get sec squared. When you differentiate cot, you get minus cosec square x divided by cot. Is that there? Nope. So that means we're gonna have to simplify. Man, so we're gonna have to simplify this. Remember, cosec is minus 1 over sine square x, and this is divided by cot, and cot is cos x sine x. So now this is minus 1 over sine square x multiplied by sine x over cos x. Because we have to flip it when you're doing division. You change the sign from division to multiplication, and then you reciprocate. Sine cancel the square. Now we have minus 1 over sine x cos x. So in that case, now you have minus 1 over sine x times 1 over cos x. 1 over sine is cosec, so that's minus cosec x, and then 1 over cos is sec x. That would be option B. That was pretty loaded. Number 10, we need to find the second derivative. So f prime of x is, remember, when you differentiate, this is now the derivative of 2x is 2 over 2x, which simplifies to be 1 over x, which is x to the minus 1. Then the second derivative is going to be carried on the power, minus 1, x to the minus 2, which is minus 1 over x squared. Option D. Differentiate cos cube. When you differentiate cos, you carry down the power 3, then you subtract 1 from the power, then you multiply by the derivative of cos, which is minus sine x. So in that case, we're looking for 3 cos square x times minus sine x with a negative at the front. Option C. This one, we're going to have to use integration, and integration by parts. ILA tell us that algebra comes before exponential. So our u is equal to 2x, so our du is 2. Our dv is e to the minus x, so our v is negative e to the minus x. Remember, you integrate this. So in that case, the formula, remember, is uv minus the integral of v du. So using the formula, it's going to be equal to u times v, so that is minus e to the minus x times 2x, and they put the 2x at the front, so I just want to follow or emulate what they're doing. uv minus the integral of v du, but negative and negative let this become positive. This is now 2e to the minus x dx. That works out to be minus 2x e to the minus x. Integrate this. By the way, this is a plus sign. Write it better. Now when you integrate 2e to the minus x, what you get is minus 2e to the minus x plus your constant c. So we can factor out what they have in common, which looks like negative 2e to the minus x, and we're left back with x plus 1 plus c. So we're looking for that minus 2e to the minus x in bracket x plus 1 plus c. Finish. Question like this, just put in a calculator. At the end of the day, you're trying to be very time efficient. That's why we buy these calculators. So we'll get them 0 to pi of fraction. This is now tan x, close the bracket. Tan x is being squared over 4. Alright, I made a mistake here. Let me see. This is What's wrong with this? Let me try again. This is bracket tan x, and then I square it. They say I'm making a mistake. I know I can put in the calculator. What am I doing wrong? Tan x. I want to square what's tan x. Might as well I would have worked it out because I would have been finished by now. But already started, so we can't go back now. Gonna write it as tan x times tan x. Maybe the computer can pick up that. Tan x times tan x. What? Alright, we're just gonna do this because this is stressing me out. So integrate this. They say using this given. So when you transpose it, you're integrating from 0 to pi. Tan square is going to be sec square x minus 1 over 4 dx. Factor out the 1 over 4, so that's 1 over 4 times the integral from 0 to pi of sec square x minus 1. When you integrate sec square x, it's going to become integrated. Integrate sec square, you get tan x, alright? And when you integrate 1, you get x, and we're going from 0 to pi. When you put in the pi now, this is now a quarter in bracket. Input the pi. Input the pi. Alright. So tan pi. So the tan of pi is 0. Tan of pi is 0. So this is tan of pi is 0 minus put in pi. Close up that minus a quarter in bracket, put in the 0, 0 minus 0. So our answer is just negative pi over 4. Might as well we had worked it out because, yeah. This question now. Find the gradient of the tangent. Differentiate x squared, you get 2x. Differentiate 2y, or y squared rather, you get 2y dy by dx. That's equal to 0. We divide through by 2, that is x plus y times dy dx is equal to 0. We bring it over, we're saying dy dx is equal to, bring it over, that's minus x, then we divide it by y. This is a gradient. So in this case, it's negative x, which is minus 3, over negative 4, which is 3 over 4. Because remember, the y and x point they give you are 3 and minus 4. So 3 over 4 is the gradient of the tangent C. Number 15. This question, they say using the substitution x as the tan theta, tangent theta. So if x is equal to tan theta, you're going to need to find your dx. When you differentiate tan, you're going to get sec squared theta. Alright, d theta, just to put that there. At the same rate, we have to remember that in the denominator, they have x squared plus 1. So x squared plus 1, you have to bear in mind that is tan squared theta plus 1, which is sec squared theta. So, and also we're going to have to change the lower limit, because the lower limit, remember, x is tan theta. So this is tan of 0, and the tan of x, put in x here, tan 0 is 0. And the upper limit now, we put in 1. Upper limit right here, x is tan theta. So put in tan, that's, that's upper limit. Alright, so, well, we really don't need to work with upper limit. No, it's pi over 4. Alright. So, actually made a mistake here. I just spotted, sorry. the lower limit now is regards to theta. So it's tan inverse. So in other words, we're saying theta is tan inverse of x. So the lower limit is 0 and tan inverse of 1 is pi over 4. So now that we have that, now we can say, oh, so now I is equal to the integral from 0 to pi over 4 of 1 divided by the square root of x squared plus 1. X squared plus 1, remember, x squared plus 1, we said it right here, is sec squared theta. So that part now is becoming, this is now the square root of sec squared theta, and it's being cubed. And then now the dx becomes also dx, we said dx is sec squared theta d theta. So in that case now, if you're square rooting sec squared theta all cubed. So second power raised to the third power square rooted, that just look like sec cubed. So in this case, I equal to, notice, square to the third power is to the sixth power, but then when you square root back, the square and the square cancel. So it's the integral from 0 to pi over 4 of sec squared theta over, what was it again? This is to the sixth power, square rooted is to the third power. So sec cube theta d theta. Now square over cube leave 1 in the denominator. So from 0 to pi over 4 of 1 over sec theta d theta. And 1 over sec theta is cos theta. So it's an integral from 0 to pi over 4 of cos theta d theta. So that's option B. That was actually a tough question. Alright, we're into module 2 now. Hopefully we can go a little bit faster. So here, bring out the calculator because we're going to save our time. So we want to evaluate the summation from 1 to 5 of 3 times 4 raised to the r minus 1. I'll put that in the calculator. That's 1023. Alright. Now this question, the equation has a root in between. Now if you work out f of 0, that would be e to the 0 minus 0. And e to the 0 is 1. So 1 which is greater than 0. Then f of 1 is equal to e to the 1 minus 1. And exponential e is 2 point, what is exponential e again? 2.71, right? So e minus 1, still bigger than 0. So that's not helping us. F of 2 now is 2 to the e to the second power minus 2 to the fourth power. We're trying to get less than 0. So change that as e squared minus 2 raised to the fourth power. No less than 0. So 1 positive, 1 negative, so the root is on 1, 2. Alright, that's it. Now this one, the value of this, so this is when the modulus of x is less than 1. So I notice this is now, you plug in 0, it's 1, plus plug in 1, that's x, plus plug in 2, that is x squared plus x cubed, and it continues. Alright, so in this case now, we notice that this is a geometric progression where the common ratio is x. So therefore the sum to infinity is a over 1 minus r. And so the first term a is 1 minus r, and r is x. Easy, option C. Easy, because this just means sum to infinity. Alright, number 19. Please just be one time. Linear interpolation. So alpha, the approximated root, is a times the modulus of f of b plus b times the modulus of f of a over the modulus of f of b plus the modulus of f of a. So in that case, it's going to be a, which is 0 times the modulus. So I have 0 times f of 0.8, the modulus of it, which is negative 0.76, plus b now, the 0.8 times 1 over 0.76 plus 0.8. So we'll just put that, well, 1 plus 0.76, I mean, mistake here. Remember, it's a modulus we're using. So then we'll put that into the calculator, fraction button, 0.76 plus 0.8 over 0.76 plus 1. And remember, in the numerator, this was being multiplied by the 0. And then the 0.8 was being multiplied by 1. And then we input that, we get 5 over 11, which is 0.45. 0.4545 or 0.455. Third term of the power series expansion, ln 1 plus x over 1 minus x. So this is really ln 1 plus x. Log a over b, so minus ln 1 minus x. And we just need to expand this right here. So the power series is when you use either Taylor or Maclaurin, but I really don't understand why they're giving me this little bit of space to work with. So remember, f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial. Alright, so this is the formula we need to use, and it's third term, so we're looking at the x squared term. Whoa, that's so easy. So I guess we don't even need to work it out because there's only one x squared term. But just for the fun of it, let's work it out, right? So we differentiate f of 0 first would be ln 1 plus x. And we don't need to find f of 0, we need f prime, f double prime. This is f of x, so f prime of x would be 1 over 1 plus x. So the second derivative would be, we differentiate this. This is really 1 plus x to the minus 1. So we differentiate it, that's minus 1 time over, this would be to the minus 2 now, so over 1 plus x to the minus 2, so it's square, right? So this is it. Carry on the power, subtract 1 from the power, yes. So then if you plug in the 0, that means the f double prime, so for this part, the f double prime of 0 would be, from here, it would be negative 1. So the formula tells us that it would be negative 1x squared, negative 1x squared over 2. And then now we have to work out for the other side. For the other side, now, this is when we're dealing with the ln 1 minus x now. So I'll just change this to 1 minus x. Then the first derivative would be differentiate ln. That would become minus 1 over 1 minus x. And then now we'd have to differentiate this again. So this is negative in bracket 1 minus x to the minus 1. So when we differentiate this, we'd be getting, carry down the power, so it's now positive 1. Subtract 1 from the power, 1 minus x to the minus 2 times the derivative of what's in the bracket, negative 1. So the second derivative is negative 1 over, so I want to make sure minus and plus is minus, so it's negative 1 over 1 minus x to the second power. Then we'll plug in the 0 again, so that is negative 1 minus 0, yeah, so negative 1. So from that it is minus, in bracket, the second term over here, the f double prime is minus 1 over minus 1 x squared over 2 factorial, and 2 factorial is 2. Well, actually, I'm having a bit of hiccups here because I am not getting x squared over 3, and they said the third term. So I'm actually going to work this one out properly. Alright, so guys, bear with me. I'm just going to go to the blank screen. And what I don't like about this question, well, I like the question, but what I don't like about the cape is that notice the little beanie space they give us. I cannot do anything with that beanie space. Can we agree with that? We can't do anything in that beanie space. So here we have ln 1 plus x over 1 minus x. Alright, and that is difficult to differentiate, so we use laws of logarithm to break it up as ln 1 plus x minus ln 1 minus x. So now, remember f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial. So in that case, f of 0 is going to be ln 1 plus 0 minus ln 1 minus 0, which is ln 1 minus ln 1 is 0. So actually, we're going to need to continue and write f double prime or triple prime of 0 x cubed over 3 factorial, because the first term we notice is 0. That don't count as a term. Now, f prime of x is going to go differentiate log 1 plus x to get 1 over 1 plus x. This part minus differentiate that part, we get 1 over 1 minus x times negative 1. But then minus and minus, let it be plus. So it's 1 over 1 plus x plus 1 over 1 minus x. So f prime of 0 is going to be plug in 0, that is 1 plus 1, which is 2. Now f double prime of x, we need to differentiate this now. So carry down the power. And by the way, this is 1 plus x to the negative 1. And this part is 1 minus x to the negative 1. So when I differentiate that, I carry down the power. I subtract 1 from the power. I carry down the power. I subtract 1 from the power. Then I times it by the negative 1 here. Then minus and minus, let it be plus. So this is minus 1 over 1 plus x to the second power. And then right here, minus and minus is plus, so now I have plus 1 over 1 minus x squared. And then I plug in the 0, this is minus 1. And I plug in 0 here, I get minus 1. Plus when I plug 0 here, I have 1 over 1 minus. So to make sure I don't make any mistake, I plug in the 0 here, I have 1 minus 0. And 1 minus 0 is 1. So that is minus 1 plus 1, which is 0. So notice that still don't give me the third term, so I have to go again. But they only have they have up to x cubed. So I'm probably making some mistake. Let's go again. Alright. So first term here, second term here. And no, that's not helping because this is saying this is 0. So f triple prime of x, alright, f triple prime is equal to, but just to make sure we didn't make any mistake in our derivative, f prime of x, 1 over 1 plus x plus 1 over 1 minus x, that's good. Differentiate this, carry down the power of minus 1, subtract 1 from the power, that's minus 2. Carry down the power of minus 1, subtract the power, minus 2 times negative 1, negative and negative become positive, so this is good. When I input the 0, this is negative 1, input 0, this is negative, yes. So f triple prime now, to differentiate this now, which is our carry down the power, minus and minus, let it be plus. Then we subtract 1 from the power, which is now minus 3. Then remember this is positive, so we carry down the power, minus 2. Then we subtract 1 from the power, minus 3, times the derivative inside the bracket, which is minus 1. So input now 0. Input in 0, this is now 2 times 1 to any power is just 1. Then minus and minus is plus. Input 0, and you're getting 2, which is 4. So the third term, remember, is this now. So now we have 4 over 3 x cubed. And I know I didn't say any 4 over 3 x cubed. Oh, 3 factorial, sorry. 3 factorial is 6, and 4 over 6 is 2 over 3. That was a mistake, guys, sorry. 3 factorial, and 3 factorial is 6. So this is 4 over 6. That's 2 over 3. Ooh, that was a lot of work. Which of the following series is arithmetic? Notice this one, clearly arithmetic, anything with 1. This one clearly out, so anything with 2 out, so 2 out, 2 out, 2 out, it has to be B. Alright, this one now. This is look like a method of difference question. So sum from 1 to n is Sn. So sum from 1 to n is Sn. So now sum from 1 to m would definitely just be Sm. So notice they're starting from m plus 1 though. So we can go from 1 to m and then go from m plus 1 to n. And that is still the sum from 1 to n, which is Sn. So this is saying Sn, and this part is Sm plus the sum from m plus 1 to n of that k times whatever. So if we bring it over, this is saying the sum from m plus 1 to n of whatever the function is, k times k plus 1, is equal to Sn minus Sm. So Sn minus Sm, which is A. It's method of, well, it's not really method of difference. It's just some summation property. Number 23, they want the binomial expansion of the x squared term. So remember, it would be a to the n plus n choose 1, a to the n minus 1, b to the 1, plus n choose 2, a to the n minus 2b squared. So this gives us the x squared term. So n is 8, so 8 choose 2, 2 to the 6th power, and this is negative x being squared. So then we'll put in this part in our calculator. 8 choose 2 bracket multiplied by 2 raised to the 6th power. This is 1792, which is D. Next part, given this right here, we need to evaluate the limit. The limit as n approach infinity. First thing though, let's evaluate the sum. Sn would be, if you put in 1 over I, that is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, all the way up to 1 over n. Then we're subtracting 1 over I plus 1 would start at 1 over 2, because this is 1 plus 1. Then 1 over 3, then 1 over 4, all the way up to 1 over n plus 1 over n plus 1. Ooh, then we notice that these cancel when we subtract. So we're left with 1 minus 1 over n plus 1. So if we evaluate the limit, this part would go to 0. So the limit is just 1. The limit is going to be 1 because it's 1 minus 1 over infinity plus 1 is 0. So 1 minus 0 is 1. Number 25, this equation here, and they want us to find the value of n. So just going to use trial and error. F of 2. I'm hoping for one to be negative and one to be positive. Just starting with 2. 2 cube minus 2 minus 3. That's equal to 3, which is greater than 0. I'm going to put in the 1 now. Change it to 1. 1 cube minus 1 minus 3. Less than 0. Very good. So therefore the root lies on 1 and 2. So in that case, n is 1. Yep, n is 1. A. Now to evaluate this question now, this is clearly a geometric progression. You put in, so we're going to put in now, we put in the n as 1, put in the n as 1, and so to get our first term, so this is 2 times 1 over 4 raised to the 1 minus 1, and so quarter raised to the 0, and quarter raised to the 0 is 1, so that's 2. And the common ratio is the, put it in the bracket, is the quarter. So now the sum to infinity is a over 1 minus r. Now put that straight into the calculator. 2 over 1 minus a quarter. That's 8 over 3. Now I'm going to plug in the computer. Just plugged in the computer and we can finish up this here. Alright, so question 27 says it says that the sum to infinity of a geometric series is 4 over a, and we need to find the common ratio. So if we have the sum to infinity, right, remember sum to infinity is a over 1 minus r, and they say the sum to infinity is 4a, and the first term is a. So in this case, we notice that we need to find what the common ratio is. Alright, so basically we need to transpose and find what r is. What is the value of r? So in that case now, a is cancelled on both sides. So 1 over 1 minus r is 4. So we can flip it. So 1 over 4 is equal to 1 minus r. So we can bring it over. So r is equal to 1 minus a quarter. And 1 minus a quarter is 3/4. That's B. This question using Newton-Raphson method. Remember the formula first. Newton-Raphson method tells us that xn plus 1 is equal to xn minus f of xn over f prime of xn. So in that case, it's going to be xn minus f of xn. Make xn the subject. So this is now x to the 5th minus, I'm just going to take out the n at the, take out the subscript n so it's less confusing. This is minus x cubed minus 25 over, now the derivative is now 5x to the 4th power, and differentiate x cubed, that is 3x squared. Make it as one fraction, multiply this up here. This is now 5x to the 4 times x is 5x to the 5 minus 3x squared times x is 3x cubed. Then we subtract x to the 5th, and then we subtract x cube. Then, well, subtracting a negative, let it become positive. Please remember that. And subtracting a negative, let it become plus 25 over the 5x to the 4 minus 3x squared. Then we'll look at like terms. So now it gone back to grade 9 math. Minus 3x cubed and plus x cubed is minus 2x cubed. And then 5x to the 5th minus x to the 5th is 4x to the 5th minus 2x cubed plus 25. That's what we're looking for in the numerator. So numerator here, D. Question 29, we need to expand this. So we need to expand this right here in ascending order, and they want the third term in the expansion. So if we need the third term and we're going in ascending powers, all right, the third term, constant is the first term, x is the second term, then x squared is the third term. So remember, it's going to be a to the n plus n choose 1, a to the n minus 1, b to the 1 plus n choose 2, n choose 2, a to the n minus 2b squared. So this is the third term. That's the third term. So in that case now, n is 6, so it is 6 choose 2, a which is 2 to the n minus 2, 6 minus 2 is 4, b is x over 2, the negative of it, square, and so that is going to work out to be, put in a calculator, 6 choose 2, which is 15, multiplied by 2 to the 4th power times, this is now negative when you square it is 1 over 2 square is 4. Put all of that in the calculator. That's why we have calculators. So this is now 15 multiplied by 2 raised to the 4th power, and then we multiply it by a quarter and see what we're getting. So what we're getting is 60. So the answer is 60x squared. Alright, number 30. It says apply interval bisection twice for a more better determination of the root. So let's zoom a little bit more. Alright, so here now the root is on the interval 0 and 1. So f of 0 is going to be anything to the 0 is 1 plus 0 minus 0, which is greater than 0. Then f of 1 is going to be, plug in f of 1, that is exponential e raised to the first power times 0.5. And then we have plus, this is now 0.5, and that's being squared. Then we subtract 3 times 0.5. I'll get 0.39, which is greater than 0. That's not helping. When I put in the 0, anything to the 0 is 1, 0, 0. And when I put in, 1, why I put in 0.5? Sorry. This one right here I did was for 0.5. That's the midpoint. And I'm going to put in f of 1 now. F of 1 0.5, and I even made this is 0.5 times x, which was 0.5. So I've made some blunder either way. This should have been 0.03 for f of 0.05, and then f of 1 where x is up 1. This is supposed to be 1, 1, where x is supposed to be 1. That's negative, so negative 0 point something, negative 0.36, which is less than 0. So therefore the root lies on 0.5 and 1. Alright, so it says apply interval bisection twice. So if we bisect it again, right, that would be 0.5 Well, bisect of 0.5 and 1 is 0.75. So now f of 0.75, we're going to put that in the calculator where x is, we'll put 0.75. 0.75, 0.75, 0.75. And so that's negative 0.23, which is less than 0. So the root lie between the positive and the negative, that is 0.5 and 0.75. That's where the root lies, 0.5 and 0.75. All right, we did our bisection twice. The first bisection, the first bisection gave us, it was on 0.5 and 1. Or do they count 0.5 as a bisection? So we can say this is 1, and the second is 0.5, and I count this as a third because this is not there. So applying interval bisection twice, we're going to work with 0.5 to 1, all right, because that's the interval where it lies. All right, so I guess they consider the 0 to 1 really the first interval, and then the second interval is 0.5 and 1, which is very funny because we only bisected once, so I find that strange that that is what they wanted. There it is, 0.75, and then we change this to 0.5 just to verify to you 1 was less than 0, and then this one is going to be greater than 0. So there it is. So we know it is 0.5 and 0.75, but since that's not there, that is the one we work with. Alright. Now we're finally into module 3, so we're going to go a little bit faster. Alright, module 3 is usually a little easier as well. So it says a bag contains 3 red balls, 5 yellow balls. In how many ways can 1 red ball and 2 yellow ball be selected? So remember we have 3 red, and in how many ways can 1 red be selected from the 3, and at the same time we want to select 2 yellow ball from 5. So that's it, 3 choose 1 times 5 choose 2. What an easy question, right? We take it. Now, number 32, it says from the letters A, B, C, D, E, the number of 3-letter words that can be made if no letter is repeated. We want to find how many 3-letter words we can select. So 3-letter, remember we have 5 letters to choose from first. So any one of the 5 can go first. Then 4-letter remain, any one of the 4 letters can be chosen. Then any one of the 3 letters next. So 5 times 4 times 3 is 20 times 3, which is 60. Now it says, in how many ways can 3 boys and 2 girls sit so that no 2 persons of the same sex sit next to each other? So basically, we don't want 2 boys sitting beside each other or 2 girls sitting beside each other. So in that case now, in how many ways can 3 boys or 2 girls sit so no 2 persons of the same sex? So in that case, we'll have to split it up. So what we're getting is like a boy, girl, boy, girl, boy. That way, no 2 persons sit next to each other. Any one of the boys can sit at this end. So that's 3, right? Any one of the girl can sit here, that's 2. Then 2 other boys remain. Any one of those 2 can sit here. Then 1 girl sit there. And the last you just have to take this seat. So in this case, when you say 3 times 2 times 1, 3 times 2 times 1 is 3 factorial. And then 2 times 1 is 2 factorial. So that's 3 factorial times 2 factorial. That's D. Alright, number 34. I remember this question, it repeats so much, but I don't remember the answer to it, so we'll work it out again. The probability that K occurs given that L occurs. So the probability of K, given that L occurs, we know it's the probability of K intersect L over the probability of L. Now the probability of K intersect L is 0.2 and the probability of L is 0.5. So we'll do the division on that 0.4. That's C. Number 35. One person is randomly selected. What's the probability that the person is female and prefers drink B? So what is the person? Probability that the person is a what? Female and at the same time drinking B. So that's 25 right there. 25 out of the total 90. Very shocked that they didn't simplify the answer to make it a little more challenging. Now, probability part finished. Now we're on to differential equations. So cross multiply. So we get, well, we can divide out y, so that is 1 over y dy. And then this is equal to 1 over x multiplied with the dx here. Then we're going to integrate both sides now. So when we integrate 1 over y, it's ln y. Integrate 1 over x, it's ln x plus some constant. Call that constant k. So in that case now, remember you can get rid of this right here. Let's call the constant ln a, just for simplicity, ln a. So in this case, this is ln ax is ln y. Logs cancel, so y is equal to ax. Finish, which is kx. They use a constant k, I use a constant a. Easy. Number 37, the displacement x of a particle at time t is given by this differential equation. They want us to find the particular integral. Now, the particular integral yp is going to take this form. So it's going to take the form of constant times e to the t. So therefore, yp prime is going to be, we differentiate this, we still get ke to the t. And we differentiate it again, we get ke to the t. So plug it in the second and the first derivative. So it's going to be ke to the t plus 2 times ke to the t minus 5 times ke to the t, and that's equal to 4e to the t. Now, k plus 2k is 3k, and 3k minus 5k is negative 2ke to the t equal 4e to the t. Divide through by e to the t, so negative 2k is 4, so k is minus 2. So the particular integral is ke to the t, so it's negative 2e to the t, which is option A. Number 38, it says 2 cards are drawn at random from a pack of 5 numbers. What is the probability that the product of the 2 numbers is prime? So, first thing, what's the probability that the product, remember it says the product, what's the probability that when you multiply those 2 numbers, it's going to be prime? First thing, what's prime number again? Prime numbers are 2, 3, and 5. So we're looking for any 2 numbers that when we draw 2 from this 10, all right, first thing, choosing 2 from 5 is 5 choose 2, 5 choose 2, that is 10. All right, so 10 ways we can choose any 2 from the 5, but we need the product to be a prime. So look at if you choose 1 and 2, 1 and 3, 1 and 4, 1 and 5. What if you choose 2 and 3, 2 and 4, 2 and 5? What if you choose 3 and 4, 3 and 5? Or what if you choose 4 and 5? Looking at which of those 10 is prime. So 1 times 2 definitely will give you 2, which is prime. 1 times 3 will definitely give you 3, which is prime. 1 times 5 will definitely give you prime. So let's see which other thing now. That is probably that the product of the 2 is prime. 2 times 3, that's 6, that's not prime. This is 2 times 4 is 8, that's not prime. 2 times 5 is 10, that's not prime. 12. This times this is 15, 20, so this is 3 over 10. So we're going to have to report this to CSEC. As we can see, the answer is 3 over 10. And CSEC keep giving the question with no solution. This one has no solution. Alright, this one right here has no solution. So that's 3 over 10. So it has to be reported. It has to. Nobody is reporting it. That's why CSEC keep putting it back and know that there's no answer. So this one now, 39. What can we conclude about planes? Are parallel, are inconsistent, or well, the best way to determine that is by row reducing. So I have 2, 1, minus 1, 1, 1, 1, 1, 1. I have 3 minus 2 minus 1. And this is now 4, 1, and 2. I would have just checked with the determinant. Yeah, you know what? With the calculator, let's check with the determinant first. Alright, I just want to check something. Alright. So no, they are not parallel. This is definitely true. We know they are not parallel because all of them go have different directions. Alright, so we know they're not parallel. 2 is true. Anything with 2 is true. So it can either be C or D. So I'm just going to work out the determinant because row reduction will take some time. So 2 times 1 times minus 1. Then we subtract 1 times negative 2. Then we have minus 1 times, cross out the row and column with the 1 in it. 1 times minus 1 is minus 1. Subtract 3. Then we have plus minus 1 times minus 1 times 1 times minus 2 is minus 2. Subtract 1 times 3 is 3. I want to see what the determinant is. Determinant is 11. Since it's 11, we know it have a unique solution. Alright, so it's this one here, C. Once the determinant is not 0, we're okay. This one here, it says, given that a square is this, then a cube. Alright, so, alright, this is what we need to work out. What is a cube now? So a cube, as we know it, is a squared times a. Okay. And a squared, remember, is 3a minus 2i. That's being multiplied by the matrix A. Okay. 3a times a is 3a squared. And then this is minus. If you multiply any matrix times the identity, let's say you multiply, look at this, 4, 0, 1, 0 by the identity 1, 0, 0, 1. Row by column. Look what you're gonna get. Alright. This is row by column. That would be row by column. 4 times 1 is 4. This would give you about 4. The next one is going to be row by column 0. Next one row by column 1. Next one row by column 0. So you notice you get back a. So when you times 2i times a, you're going to get 2a. But then now remember, a squared we said again is 3a minus 2i, and then we'll subtract 2a. 3 times 3a is 9a minus 3 times 2i is 6i minus 2a. Then 9a minus 2a is 7a. So this is 7a minus 6i, which is if the determinant is 22, find the value of a. So we'll go row by column, row by column. So with the first one, it's 2 times the determinant of 1 times, should I write out all of that? 1 minus 2, 2, 2. Then plus 5 times the determinant of, cross around the column with 5, 1 minus 2a2. Then plus 6 times the determinant of 1, 1a2. And they say it's 22. So now this is 1 times 2 is 2, then minus and minus is plus. So 2 plus 4, 2 plus 4 is 6. It's 2 times 6 plus 5 times, this is now 2 plus 2a. Then over here now, let us scroll down. And over here now, this is 2 plus 6 times, this is now 2 minus a equal 22. This is 12 plus 10 plus 10a plus 12 minus 6a is 22. 12 plus 10 is 22. 22 plus 12 is 34. 10a minus 6a is 4a equal 22. Bring it over, so 34 minus 22 equals 4a. That's 12 equals 4a, a equals 3. Easy. C. Here now, cofactor of x. So x across the row and the column with x in it. That is minus 1, minus 2, 2, 0. But then remember the cofactor sign. So this is plus, minus, plus, minus, plus, minus, plus, minus, plus. So the x corresponds to minus. So looking for minus 1, minus 2, 2, 0. Alright. So let me just circle the 4 elements. Minus 1, minus 2, 2, 0. That's what we're looking at. Minus 1, minus 2, 2, 0. That's option D. Alright, it says M is a singular matrix when X has a value of. So up here now, it's a singular matrix when the determinant is 0. So in this case, if we go up to here, right, we need the determinant to be 0. So if I go minus 1 times the determinant of minus 1, 0, x minus 1, then minus 2 times the determinant of cross the row and the column, we get 2 minus 1, 0, x, equate that to 0. This is now minus 1 times 1 minus 0, and then this is minus 2 in bracket. 2 times x is 2x minus 0 equals 0. Negative 1 times 1 is negative 1. Negative 2 times 2x is minus 4x equals 0. So 4x equals negative 1, so x equals negative a quarter. That's when it's a singular matrix, negative quarter. This one is a big repeat as well, but again, very difficult to remember so much, right? So cross multiply, this is what? Is that 2 pi or 2x? Can't see. So I'll get the paper here, it's difficult. I think it's 2x here. So multiply over and divide through by cos square. So this is 1 over cos square y dy equal 2x dx. Now 1 over cos, remember cos, 1 over cos square is sec square. So sec square y dy equal 2x dx. Then you integrate both sides. So now we integrate and we integrate sec square, you get tan y equal, integrate 2x, you're gonna get x squared plus a constant. So you're already looking for which one is in the form. Tan y equal x squared plus a constant, clearly option A. Alright, last question, then we're through 2021. So this one now, integrating factor. So first thing, integrating factor is e to the integral of k dx, right? When it's in the form dy by dx plus ky equal a function of x. So k is just 2 over x. It's e to the integral of 2 over x dx. When you integrate 2 over x, you get 2 ln x. We can bring it up, so it's e to the ln x squared, and e and ln cancel. So x squared is your integrating factor, D. So I hope this is beneficial. I hope you will understand everything in this multiple choice, and you will also swap them. So if they repeat it good, but you understand them in case they change up the numbers. All right, so 2022 coming.